So our last part of this lesson, that's all about distance, is now moving into the coordinate plane. Most of what we've been talking about now has just been on a number line, right? But now we're moving into two dimensions with, right? This is two number lines. We have an x and a y axis. So we're going to start with some easier ones. And our instructions now are find the distance between the 2 points in the coordinate plane. I actually want you to pause and you can plot these points, or for some of you, you may be able to just imagine where they are and think about how far apart they are from each other. And then we'll look at it together. So if you plotted these points, or if you look at them, one thing you notice is that they share a coordinate. This one shares a y coordinate, this pair, but this pair shares an x coordinate. And if you notice, some of our problems we've been thinking about recently, we've realized if they share a y coordinate, they're on a horizontal line with each other. That makes the distance really easy to find because you can literally just count. You can look at the distance of the x coordinate from -3 to 12. Well, how far is -3 from 12? 3 and 12 make 15. So you can see this is a distance of 15. And similarly, these share an x coordinate, so the distance is easy to just count because they're vertical with each other. And from 2 up to 11 has a distance of 9. So these have a distance of 15 and 9. But how do we deal with 2 points if they are not horizontal or vertical? What if they're diagonal with each other? Let's take a look at that case now. So in order to really be able to understand how to figure out the distance between 2 points that aren't just horizontal or vertical, okay, meaning we can't just count them, we're going to have to remember a theorem from your past. It's called the Pythagorean theorem. Now just a note, this only works for right triangles, but luckily we can make a right triangle happen, as you'll see in our next example. But I want to share with you and remind you of what this says. In a right triangle, there's a relationship that says a squared, so if a and b are the legs and c is the hypotenuse, but this relationship says a squared plus b squared is equal to c squared. This is possibly one of the most famous rules in math that even your parents remember from school once they forget all the other stuff from school. A squared plus b squared equals c squared. A lot of times people don't really realize what that actually means. So we're just going to quickly look at this. If you build an actual square on this side, you'll notice that it is, if it's a square, it's a and a here. And what's its area? Oh, its area is a squared. And if we do the same thing with this, we build a square on the edge here. Well, if he has side length b, then his area is b squared. And then again, if we do that here, see if I can do a good enough job. And if this has side length c, his area is c squared. What this rule tells us is simply that the area of this square plus the area of that square, if we smushed it together into a new square, would be exactly equal to this square right here. They're always equal. If you add these two areas, it's always equal to that area. But we can use this theorem in so many ways, and we're going to jump right now to looking how we can use this theorem to solve the distance between 2 points. You can always just plug in the numbers, and it always should work for the 3 side lengths. Let's take a look at that now. So now that we've reminded ourselves of the Pythagorean theorem, it's so useful in many different ways, but especially for us right now, finding how far apart 2 points are when they are not horizontal or vertical, when they're at a diagonal with each other. So let's do C together, and then I'll have you do D. Let's take a look. 6, 1, and 9, 5. I've plotted those here, and you can plot them on your graph paper. And the cool thing is, sometimes students think they can just count this, but remember when we start moving diagonals, you cannot just count the squares. The only way you can count is if you're moving horizontally or vertically when you're on this kind of grid. And so we have to do something different. But luckily we can use a horizontal and vertical line to create a right triangle, just like the Pythagorean theorem needs. Because watch this. If I go over this much, and then I travel up, I can get from this point to this point, kind of in a different way, not just a straight line. But what I've done is I've created a right triangle. And in this case, it's got a length, a base of 3, and the other leg, its height is 4. And in the Pythagorean theorem, we usually call the hypotenuse C, but we're doing distance, so it's also, we could call it D for distance as well. So we can just now directly use that. 3 squared plus 4 squared equals D squared, right? D is the distance that I want. And that's exactly just the relationship that we said. This squared plus this squared equals this squared, right? A, B, C. So what I have here is 9 plus 16 equals D squared. And that gives me 25 equals D squared. One reminder for us, if you have something squared, what's the opposite of squaring? It's a square root, right? And maybe you could just think in your head and realize, oh, 5 squared gives me 25. But if it's not so easy of a number, then we want to use the square root. And then in the end, what we get here is that D equals 5. And there's our final distance. Go ahead and pause right now and work on this last one yourself. Okay, go ahead and double check your work. If you set up the right triangle here, you see that it has 2 legs that are of length 3 and 7. And so we set up just like the other one. Simplify this down. Don't forget D squared equals 58. 58 doesn't have a nice square root. So we do the square root to cancel out the square, and it just gives D. But if we do that there, we have to do it to the other side, and the square root of 58 is about 7.62. So this distance here is about 7.62. I didn't write D there, but we know that that's what we're talking about. Well, finally that's it for this lesson. It was a long one. So again, happy math, and we will see you guys next lesson.